In this part of the video, we are going to look at the linked list implementation of a stack. So now you see the same ADT here, and the only difference is we are going to use a linear linked list to model the stack. So let's take a look at the picture. So if I have a linear linked list, I have a linear linked list here, and to model the stack, a natural choice of top should be this head. Okay, that's a natural choice. And now let's think about the two major operations. To push something on top, we're going to add it here. So now think about, to add some node here, do you need to traverse a linked list? No, obviously we don't need to do that, because you just relink this head and this old head node, and you get it done. So you manipulate two pointers, it's done. It's super easy and efficient for push operation. Now let's think about, how about the pop operation? Pop operation will be get rid of this one. Again, it's very easy. You just made your top here. That's all. So for linear linked list implementation, it's very simple. The code is trivial. I don't have to show you the code there because there's no traverse needed, which means the performance is super efficient, and that doesn't depend on how big is the stack, how many elements are there, because no traverse is needed. Okay, so the choice of stack implementation, linked list or array, as you have seen, like both implementations, they're straightforward and they're efficient. So it only comes down to how dynamic is your stack. If your stack is very dynamic, like for example, at one moment it might contain 0 elements, at some other moment it contain like 100 elements, it's a very dynamic stack, you might think about linear linked list. For a quite static stack, you might think about array, but truly both implementation are very efficient. Now let's think about the other choice. How about when we model this linear linked list, do we need to keep track of this end, the tail pointer there? I really don't see the point, because stack is a position-based ADT, and there's only one position the stack is interested. That's a top. So to model the tail, it doesn't give you anything, because for stack you only have access to the top. You push on top, you remove the top element. So I don't see keeping track of the tail gain anything other than trouble. Okay, and also about, how about some other fancy linear linked list? How about doubly threaded linked list? How about doubly linked list? So you have to think about, do you need them? By modeling those actual thread or actual link to the previous node, what do you gain about this stack? If you don't gain anything, don't use them. A linear linked list will be just enough in this case for a simple stack. Thank you.